Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about the idea of confidence intervals. All right, a confidence interval, it gives an interval for plausible values for a parameter based on a sample data. Confidence level, the confidence level C gives the long-run success rate of a confidence interval calculated with C% confidence. How to interpret the confidence interval. So if we calculate the confidence interval, we're going to kind of make this statement. To interpret a percent confidence interval for unknown parameters, we say we are blank percent confident that the interval from your lower value to your higher value captures and then your parameter. So like the true proportion or the true mean of whatever it was you were trying to find. Important. When interpreting a confidence interval, make sure you are describing the parameter and not the statistic. Population parameter. All right, example, interpreting a confidence interval. A recent Gallup poll asked a random sample of 1,010 adult Americans to respond to the statement, if the U.S. fails to develop a more talented workforce, it will fall behind other countries. The 95% confidence interval for the proportion of all adult Americans who would respond strongly agree or agree is 0.74 to 0.82. Interpret this confidence interval. So we would say, we are 95% confident the interval from 0.74 to 0.82 captures the proportion of all adult Americans who would respond strongly agree or agree. So I'm kind of restating what it was I was finding with my interval and saying we are 95% confident. All right, our point estimate. A point estimate is a single value estimate of a population parameter. The margin of error describes how far at most we expect the point estimate to vary from the true population value. The margin of error is sometimes called the margin of sampling error. Facts about confidence intervals. The structure of a confidence interval is point estimate plus or minus margin of error, as shown in the diagram above. Confidence intervals can be written in multiple ways. So you could keep it as like an expression, so 0.14 plus or minus 0.04, or you could solve it, so 0.14 minus 0.04 would give me 0.1, and 0.14 plus 0.04 would give me 0.18, so 0.1 to 0.18. The point estimate is the midpoint of the interval, and the margin of error is the distance from the point estimate to the endpoints of the interval. Determining the point estimate and margin of error. In the preceding example, you learned that the 95% confidence interval for the proportion of all American adults who would respond strongly agree or agree is 0.74 to 0.82. Calculate the point estimate and the margin of error used to create this confidence interval. So my point estimate, I would take those two pieces of my interval, add them together, and divide by 2 to figure out what is the number in the middle. So 0.78. And then my margin of error is that distance. So I'm going to take the bigger one, 0.82, and I'm going to subtract the point estimate that I just calculated to see how far it had to go. So it was 0.04 margin of error. Using the confidence intervals to make decisions. USDA guidelines recommend that no more than 30% of calories come from fat. A school nurse selected a random sample of meals served by the cafeteria and calculated the percent of calories from fat in each meal. The resulting 90% confidence interval for the mean percent of calories from fat and all school meals is 29% to 39%. Based on the confidence interval, is there convincing evidence that the percent of calories from fat in meals served by the cafeteria is greater than the USDA recommendation? So we would say, because 30% is one of the plausible values because it falls in that interval, for the percent of calories from fat in school meals, there is not convincing evidence that the percent of calories from fat in all school meals is greater than the USDA recommendation. Okay, so we would say we do not have convincing evidence because 30% falls in our interval. All right, go Seahawks.